Okay, I have started recording the class. So let me start discussing new materials. And then homework is very easy. I will also run the code and show you how to do these things. I request you to shut down your computer, pay all of your attention what I'm doing. Okay, so today we are going to learn non-parametric regression. Please shut down your computer. So we are going to learn non-parametric regression. Non-parametric regression. So three regressions we are going to learn. This is first one is called the kernel regression. Kernel regression. Second one is known as the local polynomial regression. Local polynomial regression. And third one is spline regression. Spline regression. So what I'm going to do, I'm going to discuss how they come into an existence. Okay, how they mathematically, how they come into an existence. And then I will give you three application, real life applications of this. How can we get this? Okay, during this process, I will explain what is kernel, what is bandwidth, and what is Taylor series. These are the things are needed. Okay. Now take a look. This is a parametric regression. Parametric regression. This is a parametric regression. Why? There is a beta. Okay. In this case, beta is the parameter. What is the definition of the parameter? What is the definition of the parameter? What? This is called unknown constant. If you watch the television during the election time, you will see that, well, there are certain parameters that will determine whether Donald Trump will become president or not. Certain parameters, unknown constant. What will be his foreign policy? What will be his economic policy? What will be his domestic policy? You understand? So parameter means unknown constants. This is a parameter. We know this is a linear model. The word linear is in there, right? We can say that this is linear. Okay. And what is non-parametric? I do not know how the function will run, or it is called the functional data. If x is in there, fx is in there, I do not know. Okay, that function could be like that way with the data, a data, but depending on the persons, another person line could be like this, another person line could be like that, another person line could be like this, another person line could be like that. Are you understanding? So how the line will work, that depends on certain things. So non-parametric regression means you are constructing, you are predicting for a functional data. That functional form you do not know. Understand? That functional form you do not know. You do not know how the function will work. So that means you are estimating these things. If mx or specifically I want to write like y equal to fx plus epsilon. Your purpose is to estimate this. Your purpose is to estimate this. So non-parametric regression start with these things. Y equal to f of x plus epsilon. Now we are going to use kernel regression. How can we estimate this? How can we formulate these things? Okay. So let me start. So down the road in your lifetime, if some data comes to you, that data you cannot approximate to any parametric form, then you can go for the non-parametric regression. Okay. Yeah, here it is. So let me write the way data appears. So suppose data appears in this format, x1 and fx1. So that means this is my x, this is my y, x1 and fx1. So in this way, data can appear x and f of xn. Data can appear like this way. Okay. After data appearing this way, so I want to know, and this data is coming from a joint PDF. This is coming, this data is coming from a joint PDF. I want to define that as a x and f of x. So what is PDF? Probability density function. So probability mass function and probability density function. Data is coming from these distributions. So, and then the functional form is this unknown functional form. I can write here mx as a function of f. I should write it in other way. So I can write it here f of xj, f of xj equal to m of xj plus epsilon j. J takes value suppose 1 to up to n. So purpose is to estimate this. So here I put y equal to x beta plus epsilon, right? This is suppose my x beta. So this is the functions that I want to find. You remember y equal to x beta plus epsilon, right? So I want to estimate this beta by using x and y's. So I want to estimate these things. How can I estimate this? So the method is kernel regression method. So remember, in this case, if I take the expectation, then what we get? If I take y, expected value of y, then we are getting x beta, because that has an error, 0 mean and standard deviation sigma, that is. So if I take the expectation in here, what we are getting? We are getting these things. Again, this epsilon has the same properties as that. So that means expected value of epsilon equal to 0, and then expected value of epsilon I and epsilon j, that is equal to 0 if they are not defined. So it is also like this if I is not equal to j, and then variance of epsilon j equal to sigma square. These are the properties of this error term. Now all derivations begins after taking expectation. If you take expectation on here, you end up with this. If I want to take expectation in here and then I want to move forward, if I take the expectation on here, see, when I take the expectation in there, expected value of this is a constant, that is a constant. Okay, even though x is a explanatory variable, but it does not have a distribution. Do you understand these things? Why expectation does not work in here? Okay, let me spend few minutes in here. Why expectation does not work in here? Expected value of y equal to expected value of x beta plus epsilon, and then it is just the x beta, and then epsilon, expected value of epsilon equal to 0. So you get x beta. Why? This is x is the explanatory variable. Why expectation did not operate over x? What is the explanation for you? Why expectation did not work on the x value? X is a explanatory variable, right? X is the explanatory variable or predicted variable. So you know that when you take expected value of Y expectation did not operate, did not work on X. Why? I did not discuss this linear model in the class. I assume that you already learned it. In order to cover more material, I did not cover this, right? Y expectation did not work on this. Y expectation did not work on it. Nobody? One of the assumptions of the linear model is even though X is a explanatory variable, predictive variable, it is not a random, it is fixed. Example. I want to give an example. Why? So suppose X equal to height. Okay? Height. And Y equal to weight. Are you understanding? Which one should be dependent variable? Normal sense is telling which will be dependent variable. Weight, right? So I put here weight. I put here weight, W. And this is the height. So suppose height equal to I take 5.6. If I take height equal to 5.6, how many weights I can get? Different types of weight, right? So I fix a height, and then this fixed height, I get a weight. Weight could be like different types. So I can get a normal distribution in here like this. Are you understanding? So then if I go to the height 5.9, then there is a different kinds of weight we will get, right? So then there is another normal distributions that we will have like this. Are you understanding? Then if you take a height of 6, then you will get another lot for the height of 6, there will be many weights, right? If you fix one thing, then that will be a lot of. So that means Y has a randomness, and then you can find a normal distribution, and then you feed this is the weight, this is the weight, this is the weight, and then this is the average line you are feeding. Are you understanding? If you read the regression model, this is the basic thing that should be discussed in the first class. Why X is a fixed? X is a fixed. And if there is a number 6, expected value of 6 equal to what? 6. Variance of 6 equal to? Variance of 6 equal to? 0. You understand? So that means expected value on constant, this is like this. So that means you are taking a height and you are getting different weight that has a distribution. So basic assumptions of the linear model is explanatory variable X, even though it is variable, it is fixed, for which you have a distribution of the Y. Clear, right? Okay. So now let me discuss this thing. So we started our model. Fx equal to, we started our model f of xj equal to m of xj plus epsilon j. Let us take the expectations over there. If I take the expected value, then what will happen? If I take the expected value in here, expected value of f of xj, if I take, then expectation will not work in here. This is the x. So this is just m of xj, and then this is equal to 0, right? Now, in terms of conditional probability, conditional expectation, if I want to write, how can I write it? This should be written like this: expected value of f of xj given x equal to x, given x equal to x. This is the way you can write conditional expectation. Why I have written like this way? Don't you remember, you write like this: expected value of y given x, equal to x beta. This is the way you can write for the linear model. Similarly, I have written like that way. Now, this is the conditional expectations. Conditional expectation in terms of continuous case, it could be expressed like that way. F of x and then join conditional density of f of x given x d of f of x. This is the definition of conditional expectations. See, I had a model in there. What I did, I want to find the expectations like the way we find the expectations. I took the expectations, then expectation looks like this. Why? This is a conditional expectation. Why conditional expectation? Because x, that means independent variable, predictor variable must be given. That could be written like that way. After writing this, now rest of the thing is just the mathematical applications. So come in there. We can write here f of x and g of x comma f of x. I'm going to give the explanations for this one, f of x, and divided by integration of, as it is conditional, it should be g x comma fx divided by d of fx. Now you need an explanation. You know this, right? Probability of a given b can be obtained by probability of a b divided by probability of b, right? This is a conditional probability, right? That has been applied in here. That has been applied in here. So this is the conditional probability that could be written like this way. This part. And that part is this part is that part. Just conditional things has been applied there. Okay. After doing this, now the magic will start. How can we estimate these things? Okay. Some people are always there to find out the way to find how to estimate these things, When you will see the figure, when I will run the code and draw the figure, you will see how the curve is going like this way. It is not like some data I put in there and then by using Excel, this. That is called the adding line. But here we are estimating. Estimating means they are doing some kind of averaging thing. Okay. Now what is kernel? Kernel is some weighting function. Kernel has a definition. It is called kind of weighting function. And suppose x values are given 5, 6, 7, and fx values are given 9, 10, 15. So you can say that, well, I will put x in here 5, 6, 7, and fx is in here. I put it in there, and then scatter plot, I just add the line. Are you understanding? Are you understanding? So someone said that, hey, professor, I want to do these things. Here is 5, here is 6, here is 7. And then you said, I put here 9, I put here 10, I put here 15. Right? And then you said that, that's my non-parametric equation. Said that, no, this is just, you are doing a scatter plot and adding the line. But scientists, they are saying that, no, you have a lot of data points in here. They said that, no, it could be like that way, and there should be unified rule. We should develop a rule that will be general, everyone can do that. In order to get this type of line, now we need to take a help from kernel. Or you will see like this way, like this way, like that way. Clear, right? You are understanding why non-parametric regression. So I have X and Y data, I want to construct this. Before constructing this, they say these things is unknown, like this function these x and y's values are known, fx values are known, how can I estimate these things? So they give a method that is called the kernel density estimation. Kernel density estimation. Kernel density estimations they are doing in here. So what they propose? They propose that this function f of x could be estimated by using kernel, which I am writing now, and then I'm explaining what is kernel. I goes 1 to n k h x minus xi, and then this could be written as this h is known as the bandwidth or smoothing parameter. I'm going to explain these things. That is the most important part, bandwidth or parameter. And then this could be written further 1 over n I goes 1 to n. This is kernel. What is kernel? I'm going to discuss. K x minus xi divided by h. What is kernel? K I'm going to discuss now. Kernel has some certain property. And then finally it is written as nh I goes 1 to n k x minus xi divided by h. Okay. Let me explain what is bandwidth first. And then I'm going to discuss what is kernel. What is kernel? I'll give you 1 or 2 examples, maybe 3 examples. Then rest of the derivation will be quick. I am not going to discuss all of these things. How much time I finish? Oh, almost 1 hour. Okay. Bandwidth means what? Free parameter. The bandwidth has another name, free parameter. Free parameter. Free parameter. Free. Everyone like free, right? Freedom, right? Right? This girl is free. She can date with anyone, not me. Right? Free. Free parameter. So that means either you can subjectively choose or there is a mathematical way to find it. Understand? So this bandwidth, if this bandwidth value is big, suppose someone took bandwidth value is 7. Try to understand. So subjective. He take bandwidth value as a 7, and he has a data like this. His data is like this. But his bandwidth value is big. He is over smoothing. Maybe it's just like this. Understand? Someone take bandwidth value equal to 0.2. Bandwidth value 0.2, then his estimate could be like this. Same person working with the same data, different values of bandwidth is giving different types of curve. Bandwidth. That is what is known as the free parameter. And there is a mathematical procedure also given so that people stop fighting, and they use the mathematical procedure to choose a bandwidth value. But sometimes if you want, you can choose the subjective choice. So you understand what is bandwidth is, right? Bandwidth means smoothing parameter, free parameter that will determine how rough or how smooth your predictive curve is. So you understand what is H is bandwidth. And then what is kernel? Kernel is a weighting function. It has 2 characteristics. Number 1, kernel add up to 1 plus infinity to minus infinity. If these 2 conditions satisfied, then f of, suppose I want to put here k of, I can put here k of a equal to k of negative a. That means symmetric. Let me tell you, if you come up with a function, and that function satisfies these two characteristics, then it will be called the kernel. Understand? Now I want to give you an example. So kernel, a function will be called kernel if that function satisfies these two characteristics. Sum up to 1. It is u. I put here maybe u, or like if I put here u, you can put here u and negative u. So let me give you an example. Okay, what is kernel? Let me give you an example so that it will be very okay for you. Suppose I want to define a function qa equal to 1 minus absolute this, where ui less equal to 1. K of u equal to 1 minus absolute u, right? I want to check whether two characteristics, that means summing up minus infinity to plus infinity, k of u equal to 1. And second is k of negative u is equal to k of positive u. If these two characteristics are satisfied by a function, that function is called the kernel. Kernel is nothing but a weighting function that will add weight when we will find the smoothing things. Okay, let me check it. If I want to integrate this minus 1 to plus 1 k of u du, check what we are getting. Minus 1 to plus 1 minus u du. Then I can write minus 1 to 0 1 minus 1 to 0. As it is minus 1 to 0, so it should be plus u. And it is 0 to 1, it should be 1 minus u du. You understand what is the absolute, how this will work, right? Are you understanding or not? So this means what? If you take out this absolute sign, this means you take value this, right? You know that, right? So let me just, if u absolute u getter equal to 1, so that means this. If this is a 0, this is a negative 1, this is a positive 1. If you take out these things, that means getter equal to 1 or less equal to 1. So this means that. This means that. And then if you put absolute u less equal to 1, that part means this one. So I take it out, I got this. So here I got u 0 minus 1. Here I got u squared divided by 2, 0 minus 1. Here I got u 1 0. Here I got u square over 2, 1 comma 0. You are understanding this? So previously it was negative 1 to positive 1. I split it in two parts, negative 1 to 0 and 0 to 1. And then as is value are negative, so that negative and this take out negative, it will become positive. But it is a positive part, 0 to 1, so this is just that part. So you understand why this is positive, right? You understand why this is positive. So if you add this up, you will see this is equal to 1. If you find this, I check it today. And the next one is symmetry. So if you put here, suppose I want to put here 0.5. If I put here 0.5, then it will be 1 minus 0.5, which is equal to 0.5. If you put here negative 0.5, 1 minus, it will be negative 0.5, then it will be just 0.5. That is the symmetry. Okay, so these two conditions. So this is one kernel that is known, the kernel that I wrote, that is known as the triangular kernel. There is the uniform kernel, there is the Ipanichnikov kernel. Okay, these are the kernels can be used in this case that I wrote in here. This kernel. So now we want to plug these type of kernels, where in this case we want to put the kernel. In this case, we want to put the kernel. And kernel is what? Kernel is known to me. Okay. After plugging this kernel, they will have a very beautiful shape. That shape will help us to find kernel estimate. Okay. So now let me go to the equations which I wrote. Mx equal to, I had these things, f of x, g of x comma fx, d of fx divided by, here is integration, gx f of x dfx. In this case, now we want to go to plug the kernel. So first of all, I want to find this one. So I want to estimate these things. We had x comma f of x. That could be obtained by j, which is the total number of observations, and h of x, one kernel for the x, another kernel for the fx. So h of fx, and then j goes 1 to 1, k x minus xj over hx plus k fx minus f of xj divided by hfx. Now you can ask me, see, take a look at that. This is the kernel, x and fx joint kernel. I put there too. Why? Because here I define the kernel estimates. This is the kernel estimate. They say if this is the unknown PDF, you do not know, how can you estimate these things? How the mathematical form is? They say this will take something like this kernel. And when I plug all of this format, it will come into this. And this has a mathematical formula. This has a mathematical formula that I just discussed. After picking one kernel, there is a 7, 8, 9, 10 kernel, or you can make your own kernel, just need to satisfy two properties, and then you can estimate this. So I borrow this idea from here and plug it in there. This has been plugged in there. And after plugging in there, if all of these things is put together, if I take this under there, then it will become like this. It will become like k hx x minus xj and k hfx, and then it should be f of x minus f of xj. That's the way it has been determined. Joint kernel has been determined. Now we want to do some kind of transformation. This is called, there is a, as I mentioned to one of the property, kernel are always symmetric. By using those symmetric property, now that entire thing could be written, like entire numerator could be written in this format. Entire numerator could be put this format. df 1 over j f sum of j. I'm finishing, this one will be finished maybe within 7 minutes, then I will give you a pause. I will give you 5 minutes break, okay? So it will be k h x and then x minus xj KHF f of x minus f of xj and d of f of, this is what. Now kernel sum to 1 under these conditions. So rest of the things I will take out from there, because this integration is operating only on this function, and this integration sum and that will become 1. Rest of the thing I will bring outside. So this is the KHX x minus xj, and that is the estimate of f at x. So here f of xj. So this is the estimate of this part. So this part was staying in the numerator. So this is the numerator part I got. So this is the numerator part I got, and the denominator part will be obtained. Denominator part is this z hat x comma fx df 1 over j and summation capital J k hx x minus xj Here again, this part will go to 1 because this is a kernel. And kernel sum to 1, and this is the part that we have. Which is equal to f of x hat. So by plugging these things together in the original function where we wanted to estimate these things, this become that w hx xi minus xj xj. What is w hx, which is equal to k hx x minus xj divided by sum of k hx x minus xj. WHX equal to what? Sum of WHX xi minus xj, that is equal to 1. So this is your final estimator. Okay, let me conclude these things, then I will go for showing you the real life example. Down the road, if you have a functional data means what? You cannot approximate that data to any format, like linear format is not in there. Okay, data if you plot, it goes like this or zigzag, corresponding to one variable. How can you feed a line? How can you feed a line? How can you draw a line to the data and find the predicted value? Okay, that is called the kernel regressions. Why? Because we are using here kernel. Okay, let me just run the code, this one. After running this code, then I will give you a break. Okay, just let me run the code so that let me do this one. Download. Open. So first one is local polynomial, which I am going to derive next. But what I derive is called the kernel regressions. This is called the my kernel regressions. So regression line together with the bootstrap confidence band, I'm going to show you from a data. The code starts in here. Are you seeing band equal to 5? This is my choice, okay? Band means bandwidth. This is my choice. So I write a function in there and all the kernel package has been used there. And up until here is there. This is the 3 chunk of code. One is local polynomial. You have to run all of this local polynomial. Okay. And then kernel, you have to run all of the kernel. And then you have to run all of the spline. After running that, for example, I run this. Now I want to show you the graph. Testing. I want to show you the graph. This is the kernel one. This is the data. What I discuss, all of these things is done in here. Okay, this is the thing. Down the road, if you have a sometimes of this type of data, these dots are the original data, and then you are feeding this line. Okay, average line again, because it is expected value, right? Expected average line in here. This is the way you can get this. Now the question is, where is this line? I want to find that value. That is the predicted value or smooth value, right? I want to know this value. How can you get this value? Take a look at the data. What data I use? Cars data, right? What is my independent variable? Speed. Right? What is my dependent variable? Distance. Right? Independent variable. So take a look. With cars, ks boot, kernel smoothing, ks, I write the function ks. Boot means bootstrapping. Bootstrapping means we are taking a sample and corresponding to each data point I am constructing. Are you seeing this line, this line, this line? So that many times I am constructing, taking a sample and constructing bootstrap confidence band. I'm constructing this, and number of replications I take here 5,000, and then with cars plot speed distributions race, and with m, which is in there, matplot x, and x means original speed variable, and then from this m data I'm subtracting one row, that means the smoothing one. So now let me show you the data, original data and then smooth data. So this is my head cars data. Okay, so speed 4 and distance 2, right? This is the original data. Now I want to see predicted data, right? So predicted data, see first one, so 2, 10, 4, 22, 2, 10, 4, 22, 2, 10, 4, 22, 2, 10, 4, 22, maybe 2, 10, this is maybe 4, 22. Are you understanding? It's 2, jump to 10, right? Come down to 4, then 22, something like that. What is the smooth value? I want to get the value of this line. So that one is in here. If you take a look at the head and m, are you seeing 7.93 and then 8.64? That is 7.93, 8.64. This is the values is coming from that line. Okay. This is the original x, and that is the y. I think x has also been scaled. Let me check. 4, 4. Okay. So what they have done in here? What they have done in here? They make the data. They make the data, x data they make is changed. How did they change the x data? Let me check the entire row. I want to see the entire data in this format. Edit. Edit M. Okay, let me check the other one then. Okay, so when LP KS boot applied, they applied the smoothing on both data, X and Y. Understand, right? You see the X value also changed, right? So they applied both. I have intention that they did not do this, but when they use KS, take a look at that. Take a look at the code. When this part is applying KS, this is applied on both of these data. Actually, both of this is smooth. Clear, right? Take a look at the original code when that one was developed. In kernel regression, when these things has been developed, in this case, if you take KS boot was applied that, oh yeah. Why did I forget this? Kernel is smoothing. This KS is smoothing I was importing on both of these X and Y. So that is why original data has been transferred to the smoothing data in both X and Y scale, and we got this graph. So in your homework problem, take a look at this one. These two data, according to their ID number, you will take two variable A's and another variable in your choice. You copy the code and you get the smoothing curve. 3 smoothing curve you will put in one graph and you will give the printout of this predicted value. Show 30 predicted values, right? So that predicted value is coming from M, right? That I showed. So that is the what you will have to show. So take a 5 minutes break, come back, and I will discuss a local polynomial then.
The band.
Bandwidth here, it is subjective. Okay, so after the 5 minutes break, what is the formula for choosing bandwidth? I'm going to discuss that. Okay.
Because in regression, ridge regression and all, we choose the penalty parameter.
Penalty parameter by minimum square root, right? Have the like the mean integrated square root will be maximum. I will discuss that. Yeah, there is a cross validation approach, right? Cross validation approach for which value of lambda mean square error is minimum, right? Right? Yeah.
We put the value alpha.
Yeah.
We put the value alpha, when it's 0, it behaves like a linear regression.
Yeah.
And as we increase it, it puts the more we increase it, the more penalty.
More penalty, like more zigzag.
Yeah.
Yeah. So there is a way to choose that parameter that is called the cross validation approach, and also how to choose bandwidth. I will discuss this after the class. I have a formula.
Because in the homework, how I had chosen was as I was increasing, at some point of time, the R square value was decreasing.
Yeah.
So for the maximum R square where it had.
For maximum R square value, choose the lambda value. Okay.
I'm not sure.
Okay, one of your classmates asked me question. bandwidth we can choose subjectively, as I mentioned. Bandwidth value can be 2, 3, 4. Is there any unit rule, mathematical rule that we can use? Yeah, that is the mathematical rule. This is the mathematical rule. See, for each value of age, I can choose 100 value of age. I want to find this kernel estimate divided minus original value. Fx is the original value, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Fx, x, and fx. Corresponding to x, there is a fx value. We can put there. These value we can use by using kernel. By using kernel, I can estimate this value. So now, for each value of that, if I find this like mean integrated square root, if I find this for h equal to 2, I got a value. H equal to 3, I got another value. H equal to 2.5, I got another value. H equal to 1.5, I got another value. In this way, all the values that I got, the minimum one that I got, corresponding to that minimum mean integrated square value, I will choose the h value. Suppose h equal to 2.31, I plug, and for the 2.31 and other values of h corresponding to 2.31, if mean integrated square error is minimum, that will be the value for the bandwidth. This is the formula, cross validation approach. This is called, and there is a other approach like one subject out, at time point out, all of this. So, but those will be a lot of discussions. If you are interested to like how to do the cross validation approach, you can read some papers. Maybe my PhD dissertation is one of the options. Okay. After doing the kernel regressions, now we want to learn what is local polynomial regressions. Local polynomial regression. Okay, kernel regression was proposed 1964. 1964. This one is 1977. Okay, the statistics, all the models that you are seeing, this is even not a, many of these things in even are not a 100 years old. Okay, Ridge regressions, I told you 1970, Lasso 1996, elasticness 205, and recently another very important things was developed, which is called the LOCO. If you use the LOCO in any machine learning model, then p-value approach does not need it. Okay, maybe down the road one semester I can also include these things in the syllabus. Okay, the p-value approach, you take a look at the p-value and then you said that this is significant and this is not significant, right? But if you include the LOCO one in any predictive model, then you can quantitatively find. This is quantitatively most important for the model. Currently, if you feed a regression model, can you say this is this covariate, this independent variable is most important? Now you cannot say that. Are you understanding what I said? So if it is a regression model, all p-value is less than 0.5. Which one is very important? You cannot say that. But if you use the LOCO, which is developed 2017 by Stanford students currently working at a Carnegie Mellon University, and he developed this approach. By using this approach, we already submitted a paper. Understand, right? So down the road, when people will become familiar with these things, it is just 5-6 years now, they will start using LOCO. All the models, they are going to use the LOCO. So local polynomial regression was developed by Michael Stolin in 1997. How this come into an existence? What is the mathematical formula, right? So the rationale for teaching material for this course throughout the semester, I try to give you an explanation how, right? Negative binomial regression, Poisson regression, quantal regression, how, why, right? That is the most important thing. Why should I using? That things was mathematically justified. That is why people accepted these things. Okay. Down the road, if you do some applied researchers, they might be very mad. Oh, I don't know what is the math. Why you are doing all of these things? If this math does not stand solid, then talented people will not accept the model that you are proposing, right? there is a rationality why you are doing these things. Then you have to convince those talented, super talented people that rationale is this. So now how this model come into an existence? Local polynomial, did I write? Local polynomial regressions. Local polynomial regressions, as I write before, I write before f of xj equal to m of xj plus epsilon j, right? This is what I write, right? This is what I write. So this is the model. I do not know the mathematical format of this. Clear? So, but a scientist give us a rule that is called the Taylor series. Taylor series. Okay. Taylor series, you can expand any mathematical functions, either real or complex. Do you know the complex function? Minus b plus minus b square minus 4ac divided by twice a. If minus b equal to 7, and if I plug all of in there, suppose there is 29 divided by 4, then what is this? Complex number, right? This is a complex number. So this gentleman, he said any function, real or complex, that can be expressed by this series. And by borrowing this idea in 1977, that gentleman applied Taylor series on this and expanded it. Okay. After doing the expansion, he subtract right part from left part, and he said that this is my local polynomial regression. That's easy things. You understand? So our model is this, right? Our model is this. The problem is we do not know about this, right? Our non-parametric regression models, what is the main problem? We do not know how it is going. From the data, that will determine it is going like this way or that way, this way. And each of you will use different bandwidth value. Your curve will be different from the other. Are you understanding? And if 100 people work on the same project, if they use the different bandwidth value, different type of smoothing values you will obtain. In order to make a unity, they have also given a bandwidth formula. This is the question. She asked me, Samida asked me, how can I find this H value? Mean integrated square error. For that H, this expected value is minimum. We will pick that as our bandwidth value. Okay. So in the exam, if I ask you what is bandwidth, how can you select that? Your answer will be bandwidth is a free parameter or bandwidth is a smoothing parameter. We can select that by using cross-validation approach, or we can find bandwidth value for which mean integrated square error is minimum. Understand? I said this already, right? And it is on the video. Okay, watch the video. Okay. So take a look at that. Let me write the function. Let me write the Taylor function. Taylor define any function fx. Any function fx. This is the Taylor series I am writing. Exactly, they use this thing. Taylor gave this series. This series is expanded at a. Fx is a function at a. This series is expanded. it will go second derivative, third derivative, all the way this. So this is written as n goes 0 to infinity, then f of n a divided by factorial n x minus a to the power n. If I would have more time, then I can give you a real life example. This is the function. Let us use this function, but let us express that function in this format. But maybe sometimes, if at the end of the semester you can tell me, or maybe I can come and show it in the next class, what is how the Taylor function is. So what this statistician did in 1977, he just applied this series on the function fx. Understand? He just applied this series. So what he write? He write like this way. He write like this way. Fx is written by using Taylor series, sum of beta q a0 over x minus a0 to the power q. For x in some neighborhood of a0. This is called for x in some neighborhood of a0. This is what that is. So now if this formula is applied to our function, so our left-hand side is f of xj, which is equal to y. This is our y, f of xj, and that has been expanded. This function has been expanded by Taylor series, right? This function has been expanded by Taylor series. And then after Taylor series expansion, suppose this function like this, then what he did after expansion, these things, what he did, he brought it in here by minus sign, and then this is a function he is mentioning. So what f of xj, he expanded it in this format, and then he subtracted this from that. So like the way you write like this, x beta plus epsilon, and then what you did, y minus x beta equal to epsilon, which is called the error. You expanded this and subtracted it from there, and you call it as a error. That's the idea. That's the whole idea. So after writing this, it is going like that. He is writing j goes like this, f of x j, and it is written p, and q goes 0 to p, and beta q x j minus x to the power q. After doing this, and then he is taking the square of this. That is, see, this is the Taylor expansion of that. This is the Taylor expansion of that. This part is just the Taylor expansion of that. There is a beta q, definitions of beta q. How the beta q's are determined is mentioned in here. Beta q is defined like this way. Beta q x has been defined as f of x to the power q. This is the number of derivative divided by factorial q. This beta q equal to this. Okay. So that is the regression format. But this is a non-parametric regression. Non-parametric regression needs for smoothing parameter. Smoothing parameter. Okay. So in order to bring the smoothing, because there is no h in here. There is no h in here. Okay. You study the weighted least square. Weighted least square you study from the econometrics class, right? You took the econometrics class with Dr. Chauhan, right? Weighted least square. So that means they multiply by some weight in order to normalize the, in order to bring the non-symmetric data, skewed data to normality. So here, this gentleman is multiplying by this kernel in order to bring this bandwidth in here. Now bandwidth comes in here. Just a weighting function. So what is this part? This part is nothing but a weighting function. Weighting. This weighting function they have multiplied in here. So after multiplying in here, they got this format. This is the format. But in order to estimate those things, they beautifully express all of these things in a matrix format. And in the matrix format, they got a final expressions. So let me write how to do, how to express these things in a very beautiful matrix format, okay? So in order to write the matrix format, fx is written, these are my all y values. Transpose. And this is my betas. If you see here beta, don't start fighting with me. Hey, professor, why did you put here beta? This is called non-parametric. But beta is a combination of fx. I have shown that, right? Beta is a combination. Beta is expressed in terms of this. Okay? Beta is just the notation that is directly coming from the function and some factorial values. So this could be written as beta 0 x and beta p x transpose. And then G is a x comma h, which is written as a diagonal of kh xj minus x with the jth column x comma h equal to 0. It is a diagonal matrix only as the jth column has an element xj x like this. And then T px is the matrix with its jth row given by so in the matrix notations that I just defined, these things could be written as follows. The way I define the matrix notations, these things could be defined as then pth order polynomial, pth order local polynomial smoothing estimator after minimizing with respect to betas. This is the local polynomial smoothing estimator. So here we can find these things is defined as xjx comma h equal to q plus 1 p plus 1 x this is t pp, and then that super script is just a transpose. So that's the all expressions of the local polynomial regressions. So let me tell you, when I was doing PhD, professor come one day, and one day he derived one regressions, all the mathematics, all of this, and one example. But in your case, I want to give you all applied training so that you can know how to apply these things in real life problem, right? And that is why in one class, I try to cover a lot of models, but give you the rationale how this come into an existence. The main idea is that there is a function, non-parametric regression functions, that we do not know how to move, how to go. How can I write that function? Okay, so there are a couple of others, but I just want to discuss three. One is kernel regressions. I have shown you how that come into an existence. There is a kernel. By using kernel, they estimate unknown functions, and finally you got the estimated functions. Here in local polynomial regressions, there is a functions, that means fx, which you do not know which way to go, but they apply here Taylor series. After Taylor series expansion, they subtract the right side from the left side, and then they square it, and then multiply it with a kernel in order to bring smoothing parameter. The smoothing parameter was not with the regression. So like the way weighted least square method, where you use multiply or divides by some weight in order to normalize, in order to satisfy the normality assumptions. Here, this gentleman, after local polynomial expansions by using Taylor series, he multiply it by a kernel, in here. This kernel give him an opportunity to have a smoothing parameter in this function. See, this is the Taylor expansion. This is the right side of this function. Right side of this function is that which is called the error square. This is the error square. So in the error square, he multiply by kernel in order to get the regression format. Now he do some mathematical formulations, and then finally estimated the regression format. Clear, right? Clear. So now let me take you to the R code. So this is the local polynomial one. If you take a look at that, local poly, x and y, kernel I use here Ibanez-Neikov kernel. Okay, I will show you what is Ibanez-Neikov kernel. Bandwidth and band. I just put a band there. Here it is subjective choice that I made before. Are you seeing band equal to 5 in the first one? Band equal to 5. It is subjective choice. Okay, but from the data and X and Y, this X and Y, from the data and X and Y, there is a cross validations. And now if you just put the X and Y as well as like the local poly things, they will give you a list of bandwidth, and corresponding to bandwidth, there is a mean square error, integrated mean square error. You will pick that bandwidth for which mean square error is minimum. Okay, so we have run this complete thing. Now go to the local poly one. Local polynomial one. So I want to take a look at this one. There is the local polynomial one. Okay, so one important thing I want to tell you. Down the road, if you have a time series array, in fact, in your homework, I give you a age variable. Okay, in your homework problem, I give you age variable, and for the dependent variable, I have given you freedom. You can choose height, you can choose weight, you can choose SBP, DBP, whatever you choose. Okay, so and then I ask you construct a graph like this one. So code is in there, you just need to do these things. But if anyone do these things by using Python, do not share it with anyone. Okay, you do not know what grade I'm going to give you. Okay, but if you do it and share it with everyone, then nobody will get it. Do you understand what I said? What type of code and materials I'm giving is in the R. If you can do the homework by using Python, the homework, if you can do the homework by using Python, the package is in there. I saw that. You have to find the package and then you have to do the homework by using Python and just this type of graph. And output you will give, then you do not know, right? At the end of the semester, you will go different places. And then you can say that you gave him A, not me. I said, you cannot tell other people grade, right? If she complained me, you gave this guy A, not me. I said, no, you cannot complain. This is, I know because he did it by Python. And I already know what you are doing. And you notice that I go each homework, right? Each homework I go and I spend almost a day to grade your homework. So try to do this homework if you want to get a good grade. Okay? Okay, let me start now doing the final one, which is called the spline regression. Okay, at this point, anyone has any question?
Kernel regression and local polynomial regression. So what's the rationale for going further to local polynomial regression?
Okay. So are you seeing this graph? Kernel regressions cannot perform well in the boundary of the support. In the boundary, so like in the lower boundary and upper boundary, kernel regression estimates may not be good. That is one of the limitations they found. Okay, unstable estimate in the boundary of the support. So that is why they use local polynomial regression. My PhD dissertation is on this material, but I did not use this simple thing. I use like distribution function, how to compute unknown distribution function. I had 2 publications in a good journal from there, and I also got 2 awards from American Statistical Associations for my PhD works. Any other question? Any other question? Think about this. Any other question? Okay, let me go to next topic.
Oh, I was going to ask you to.
So I am uploading all of these materials in the YouTube channels that I send you the link, right? So that is why last few days I'm not uploading it in the Western Online. You got my email, right?
Yes.
Spline regression. Spline smoothing. The concept of spline was using long ago. So like maybe 16, 15, 17th century. And then first mathematical model is come in 1924. Anytime if you read any scientific things, try to remember who developed it, how this come into in people's mind. Okay. This year, the person who got the Nobel Prize in economics is a Harvard professor. And I read just on what topic she got it. So some labor market or something like this thing. So nobody knows who will do next 20, 30 years. Okay. So the lady who got the Nobel Prize in medicine, do you know her history? Do you know her history? The Nobel Prize in medicine. She is the person who did not get tenure at UPenn. She did not get any funding. University of Pennsylvania, and she was fired. She went back to his country, Hungary. But during that time, when she was writing proposal of her research area about mRNA, messenger RNA, right? Based on what COVID vaccine was developed by BioNTech as well as Moderna, right? It is their work. And she was giving interview. She was said that I was not get well treatment in my life in USA. She was sometime in this university, sometime in this university. She was submitting this proposal for funding for her research. Understand? And the people who are sitting in the top, they are not understanding. They are not understanding, no future. Because they will give $3 million, $4 million, $5 million. Understand? So if they do not understand, something do not come to their mind in the people sitting in the top, how can they get funding? So, and she was very upset because in academia life, if you go to the top university for a faculty, you cannot believe how much stress you will have to take in your life. Not only good publications can do, but bringing funding is very competitive. I wrote a couple of places for funding, but the people who compete with me, they are from Stanford, they are from Harvard. So if I stay in a normal university, In genuinely, right? In genuinely, it will not hit to the head of the other people. Well, this guy will be able to do this or not. Understand, right? So the people who are sitting there, they do not have that mental or psychological development, or do not have that thought level that this has a potentiality. So she regretted in her interview that she did not get any funding. And then when she went to the Hungary before getting Nobel Prize, her name is coming again and again. She is going to get the Nobel Prize. And her mother told her, you are going to get the Nobel Prize. And she is replying to her mom, Mom, I never get any funding. I did not get tenure, permanent positions. I came back to Hungary. Understand, how can I get the Nobel Prize? And after getting Nobel Prize, she gave this interview. So that do not give up. And also remember, you have a novel, suppose she has a novel idea. And because she studied a lot of things, she understands that there is a potential. But I was unable to reach in her level. And I am the person who will give the grant. As I do not know, so I cannot give you, because I understand some other people project. Oh, this is a potential. This is really, oh, they come up with that. Okay, give it to them. And people do not have sometimes lot of time to take details of all of these things, because they have family, they have job, they have work. So people fly from here to National Science Foundations, and grant comes and they give, okay, you will review these 15 grants. So 15 grants I will review. So how much time? If I spend 1 hour, that is not enough to read a 15-page scientific documents. Are you understand? Are you understanding? So immediately I say, well, this guy is coming from Stanford, or this from Harvard, or this from Carnegie Mellon. Okay, put this. Or this guy is from this university. Okay. And then take a look back of their history. Oh, he did PhD from there, he did PhD. So automatically you get some tick mark. Understand? So from this level, if you want to compete on people in that level, you have to reach at least close to them. So the women, her interview was very frustrating. Like, because the people did not understand what type of research she is doing. And now, previously, all the vaccine was egg-based. Egg. Take a look. There is a factory in Pennsylvania. How vaccine are produced from chicken eggs, all of these things. And now it's become so easy, mRNA-based. Very easy, very simple. I worked on a project for booster one for the Moderna before coming to this place. Let me conclude these things before going this. I have few minutes. Suppose a new disease arrived, right? All type of disease that are coming to the planet, we have an antibody to fight with that disease. We have an antibody. But when disease arrives to our body, our antibody take time. How can we tackle these parasites? Understand, our body take time. Our body take maybe half hour, 2 hours, 3 hours. By this time, the parasites grow exponentially. And by the time antibody decides to attack it, but the parasites number is exponentially higher. That is why when COVID starts coming, is 1, 2, immediately within few seconds is become 200, 300,000. And this is within 1 hour, it's become 1 million. By the time our antibody understand the psychology, how to attack these things, it is the number of antibodies outnumbered by the parasites, and then what vaccine do? What vaccine do? So for example, the COVID virus, that has a spike, right? That has a spike. The spike has a protein, right? Specific types of protein, right? So our body was given that specific type of protein. When our body got that specific type of protein, our body got, but that is dead. That is not active, inactive. Same protein, but inactive. So when our body received that inactive protein, same kind of thing, our antibody, oh, something comes in the body. Okay, let's do this. So our internal antibody think about this. They said, well, so let us fight it. So he is now well prepared. He got training. Our antibody got training, well, so this type of things come, so let us. Now when the real virus come, because they are already training, they start attacking immediately. That's the way the vaccine, all the vaccines is working. But flu vaccine is working, already existing in the planet. So that is why this vaccine was developed very, very quickly. Okay, very quickly. Anyway, let us do the spline smoothing. Spline smoothing is what? It is a kind of Ries regression. When I write the formula, you will see it is a kind of Ries or lasso regressions. Ries and lasso has a parametric form and that a penalty, and here is non-parametric form and penalty. Understand? So you already know Ries regressions. Ries regression has a parametric form plus a penalty. Here, a non-parametric form plus a penalty. That's the difference. It is called the spline. It was existing in the mathematical literature for some kind of predictions like this, and then it was borrowed and applied in statistical literature and solving a statistical problem in around 1995, 96, something like that. Spline regressions. Okay. So let me start discussing how the mathematical form of this looks like. So again, this is the regression format in the expected formula format. F of x given x equal to x. So this is when you take the expectations, we got this thing. This is what we need to estimate. We need to estimate this is. Okay, so now they write here like spline regression. If you can write here SR, spline regressions, J goes 1 to so in the Ries regression, what you do? Y minus x beta, right? Y minus x beta and y minus x beta, and then you do lambda sum of beta j square, right? So this is what error, right? This is also the error, right? Same things they have taken. Here they use a penalty. That penalty is known as this. And I have to write something in here in order to clarify. So let me write these things and then explain. Where H is a smoothing parameter chosen by cross-validation approach. Where H is a smoothing parameter chosen by the cross-validation approach. Now, if we want to write mx, see, in the case of kernel regression, these mx, we took the expectations and there is a numerator and denominator, and numerator and denominator we estimated by using kernel approach. But here they are doing here basis approximations. It is called in spline regressions, there is a B-spline basis approximations. They are considering this and Jx and theta j. So j takes value 1 to capital J, where and j are and j dimensional set of basis function for representing this family of natural spline. So after above reparameterizations, after above so that means these reparameterizations, the optimizations problem becomes optimization problem, theta and h will become this. Xj So now some derivatives needs to be taken, and then finally we find the estimates. I have already added this material to the online. And in order to understand more how the spline works and what is the difference between spline and B spline, you can read that paper so you can understand more. So functional data is very prevalent in the research. Okay, functional data you very much prevalent. If there is a time series data does not follow any model, then Darwin-Watson test you conducted. The Darwin-Watson test does not give you any autocorrelation. If there is no autocorrelation, then that means you cannot run autoregressive model, which I'm going to discuss from 10th week. 10th week, I'm going to discuss 10th week to 15, 16 week, I will discuss all the time series models. Okay. So by defining the basis matrix and penalty matrix, so now let us define some matrices. It will take like this. If n and this belongs to real, it's just the notations. These two belongs to real, and nij goes to nj and xj, and finally these things. If you do not understand these things, read my one paper that is published in the South African Journal of Statistics and Journal of Japan Statistical Society. These two have some little bit of extensive derivations for this. For I comma j equal to 1 to up to j, then the problem becomes then O, theta and h becomes in a matrix format, n theta plus h and then finally if it is differentiated, then this is the result is obtained. in here. With smoothing spline and this is the final format. Okay, so let me give you the example of this one. Then you will see, and finally I will see the three figures together and visually inspect to see how they are different. Okay. This is the spline smoothing. This is the spline smoothing. This line of code that you are saying, in this case, I am smoothing. Are you seeing smooth spline? Smooth spline. So this is coming from a package that I already installed in there, and then rest of the thing I am assigning here different kinds of like predictions, bootstrap things, finally confidence interval. All of these things I am putting in inside there, and after running these things, mainly actually these things is running smoothing as well as constructing bootstrap. So this is the code like spline boot that has been written in the format of a function from all the way here to here, all the way here to here together with some comments, and finally I'm running this code for the cards data. This is our cards data. Cards data. So we are running it in there. So now testing smoothing on the cards data. This is the spline one. So if I run it, spline smoothing like this. So for example, if I want to change it to now, suppose I want to change it to SPAR. So suppose I want to change it to 0.15. Previously it was 0.75. Now I change it to now go run that one. Are you seeing? What is the difference is in here? The difference is that I make a very small bandwidth. Small bandwidth means you will go like small bandwidth means smoothing parameter. Smoothing window is very small. So that is why this is so much zigzag. Smoothing. Right. So for example, if you want to take a look at that one, I put there 5, right? I put there 5. Let me put it in here just. Suppose I want to put here 20 and see how it looks like. It could be just a straight line maybe. KS boot. And then I put 1. Done. Now come to the kernel one. This is the local polynomial. This is the kernel one. It's very smooth, you will see. See, it is going outside of the bootstrap confidence interval. That is not acceptable at all, right? If you send this type of figure for publication in the paper, immediately kicked out. Right? So now I want to see some zigzag. If I want to see some zigzag, so come to the kernel smoothing instead of put here, suppose 1.2. Previously it was 5, right? Now run the kernel one. See. So there is a procedure. That procedure needs to be followed. Always use cross-validation approach. And definitely, I did my PhD almost more than 10 years ago. So like 2013, December 17, I defended my PhD dissertations. By this time, lot of packages is in there. So people in both area, they are working. So computer science people, operation research people, and finance people, they are working there. And statistics people working there. Statistics people, they like R, and then non-statistics people, they like Python. Okay. Try to do this homework by using Python. At least spend 1-2 hours. Okay. So let me discuss a little bit about the homework. Homework is in here. Download the homework. For this homework, you must use C1 BDHS data and C2 CPD data. If your student ID is odd, use C1 BDHS data. And if your student ID is even, yes, use C2 CPD data. Please follow the step below to fit 3 non-parametric regression model. Subset the data, this data by taking 2 variables, such as age and another continuous variable. So age is fixed. Okay. Age is fixed and another continuous variable you have to pick. Age will be independent variable and is denoted as X, another variable by your own choice, such as SBP, MTFBI, height, weight, or RH, RW, body mass index. This is the variable you can choose. Okay, one of these. Denoted by FX. Denote new data as D2, which will have only 2 variables, such as age and another continuous variable of your choice, as mentioned above. We want to fit above 3 models. Above 3 models. MX equal to FX plus E. This is arrow term, right? So, where Fx is the unknown regression function and E is normally distributed with mean 0 and variance sigma square, and Y equal to Mx is a dependent variable. Fx is a function which is unknown, that is no parametric form is known. So the data that we are going to use to identify relationship between X and unknown function Fx is known as a functional data. So the data that are going to use to find the relationship between X and Fx is a functional data. If someone down the road asks you, I'm doing functional data, so that means they are doing non-parametric regression. What? Why?
Why don't we use the non-parametric for any date?
Okay. If there is some parametric form, the parametric form, if you know, that has a better efficiency compared to the other. Okay. I also ask you questions. Do you have any question? You are not asking me a question that I really wanted to hear from you. Okay. Okay. Oh, I will give you time. Okay. After doing this, so she asked me question, why we are not doing all of these things, right? So I answered that if there is a some, for example, if you all the time, if you will do these things, but if the count data, we know that follow specific distributions, right? We have a better explanations from there. So take a random sample of size 100 rows from the D2 data. So data that you are using first subset the data by two variable, age and another variable. So now the cars data has a two variable, speed and distance. You will also have a age and another variable in your data. And after you have the data, so that means what you will go, you just go there, copy this, run this code, and just you need to change in here. And above part you do not need to touch at all, right? The part, the main code is in there. Main code is in here, part 1, part 2, part 3. Main code is in there, where you do not need to make any touching. You just come these 9 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9. These lines, where you will change, class data you will put your data. This should be same. Change the variable. This should be age, this should be your variable LDL. Rest of the thing keep as it is. Okay? But if your figure jump out from the line, you are going to get 0. Understand, right? You are going to get 0. If this type of figure, if you submit anywhere for publications, okay? Next time, if you will submit, they will immediately say, no, we are not going, we are going to take a look at his paper. Yes, good questions. Here you can put discrete, but Y1 you can easily put the continuous data. Yes. So you see these things, and then how to look at the 3 figures together. If you just this and run this, all 3 figures together is coming. Okay?
Nice.
How is it nice? So let me do is MF row, right? 1 row. Let me do 1 row, 3 column. Okay. Okay, next Thursday will be your exam. First half an hour, 30 minutes, 40 minutes for coding part. Okay. 30 problems that I gave in one document. Another documents I gave you 84 problems. And then Python code was given. Go over all of those. As a data analyst, as a job, if you will start, you need to have a solid expertise on that area. Understand? You have to have a solid expertise on this area. Any type of job you will do, they will need these things. So those 84 questions, 84 problems that I set up by using my experiences, by thinking how students should learn coding, this is the main data analysis part. 80% of your time for predictive modeling or any data analysis, data scientist job, 80% of your time will be gone for that. And rest of the models that I have given you, you are going to use these things. Okay. So these are the coding part, and then another part is technical questions I am asking you. You have to write 1 to 3 sentences. As many questions possible as much I will make from all the 10 models. Okay. All the 10, including this one, non-parametric one. Okay. Ultimately, you need to have expertise on this model. So when you write your resume CV, first write first section. First sections you will write executive summary. So what type of models you know? Understand? So what type of models you know you have used? So if by reading these things, if the interviewer says, well, are you sure you are doing these things? Then get preparations for that. I can show you my resume, how I wrote my resume. I first write my executive summary, my teaching, and my publications, how many publications, how many citations, and then what are my expertise, what are the models I know. Okay, these are the things I have written. So if you write like that way, first things they want to see this thing. Oh, you know all of these things, and definitely they are going to ask you the questions. So that is why I made your exam so that you know the situation I have to use what type of models. Okay, then how many models I discussed? Altogether 10 models so far, and then another maybe 5-6 model I'm going to discuss from week 10 to week 15. These are all time series models. Okay, so if you really read the materials, try to understand, I hope your exam would not be difficult. Okay, any questions? Someone want to ask a question? You want to see my CV, right? How many minutes? Can I show you quickly? Just a second. It will not take. See, executive summary I wrote, and then here I wrote I have 23 peer-reviewed publications in applied methodological journal. See, applied in methodological journals, where I have used statistical method sizes, multiple regression, binomial regression, Poisson regression, negative binomial regression, logistic regression, Cox proportional hazard model, competing risk model, Kaplan-Meier curve, generalized estimating equation, quantal regression, kernel regression, local polynomial regression. These are the things I already used in publications of the paper. If I use these things at publications of the paper, so interviewer knows me, right? Besides that, I have did a lot of consultants in very, very different places. Okay, so if you write an executive summary, so you can write here models that I learned from coursework. Right? You understand? You can write here models that I have learned from coursework, and the models that you have learned from me, you can write those things. And besides that, I'm teaching next semester 2 classes. One is business analytics, another one is called the data mining. In that case, I'm teaching. In that course, I'm teaching like classification, clustering, neural network, and what are the logistic regressions, Cox model. What? Yeah. 435, yeah. No, 435 and 535, right?
Yeah, just data mining. Just data mining.
Yeah. Yes, but the materials here you predictive modeling. There I will teach you machine learning model, classification, clustering, neural network. What? I forgot what?
K means.
Oh, K means clustering. Yeah, K means clustering, classifications, logistic regressions, Cox regressions. These are the things I'm going to discuss that model. Okay. So the reason I have shown you my CV, if you write like these things, executive summary, models that I have learned from coursework, and then all the models, if you write in here, then employer says that, well, this guy could be good for my predictive modeling thing. Are you understanding?
Professor, can
Yeah.
you scroll up?
Or then I wrote here machine learning models. Okay, these are the machine learning models. I know, but I never publish these things anywhere. But I know these things. Teaching, okay, and then teaching, mentoring, supervisions, other works, industry experiences. So there's a lot of things. So take a look at that machine. Okay. So then I write here my mentoring and supervisions, other works, industry experiences. Yeah, I know SQL, SPSS, SAS, JAM, all of these things I know.
Professor, you're not teaching us SQL.
Yes.
SQL is very easy compared to R and Python. It's just altogether select. Nothing. This is everybody. SQL is nothing compared to R and Python that you have learned. Okay, and by using SQL, you cannot do any predictive modeling. Just the data subsetting. Data is in the server. Select. That's it. If someone say, listen, if someone say he knows C++ in intermediate and advanced level, then I said that, well, these guys know something. So if someone know mother, then he knows everything, right? Mom introduced the baby to everyone, right? This is your aunt, this is your uncle, this is your everything, right? C++ is the basis.
So, Professor, do you have 2 masters?
I have 3 masters. Masters.
First class.
And don't you see when you email, immediately I get you get a response from me. Most of the time I'm doing researching, reading something, or working. Because you know some people they watch movie, and they are so fascinated. Anytime movie comes, they want to watch the movie. Some people likes music. Oh, this music, let us. So that's the way every people different, and this will grow systematically. I like to study, learn something new. So that gives me pleasure. You understand? And some of the people want to like soccer. My Saturday and Sunday, every 5-10 minutes, I want to see which team is winning in the English Premier League. Soccer and study and my family, my 2 daughters I'm raising. Okay. So I showed you, if you want, I can share this CV with you, but you just keep to yourself. If you format your CV, please, I take this advice from me. If you write the executive summary and write here, models that I learned from coursework and all the models, if you write here, believe me, you will get a.
Please share with us.
Yeah.
I'll send that.
Understand? And then rest of the thing, new educations and other things, if you write side by side, then it have a higher visibility to the employer. Okay. And all the questions is coming. Read all the models that I gave to you. How to estimate the parameter, how to explain the parameter. Okay. So what does residual deviance means? Okay. So how to check the model fit better? Okay. What is the violations of the model that we are going to use this one? What is the limitations of the rees that can be overcome by the lasso? Okay. What is the limitation of rees and lasso that can be overcome by the elastic net? Okay. So in one class that you have learned so many models, if you tell some other people, are you sure, did you learn something from that class? What did the professor teach? And I taught something derivation and give you the homework, right? At least you try to do the homework. At least you can address something on what situation we have to use the elastic max. So that's the reason purposely I am giving you as much material as possible so that you will not have trouble or deficiency or limitations in your job market, in your job life, personal life. Okay. One more final question. Who want to ask question?
Yes. At the beginning
You
of
already
class,
asked a lot of questions.
you said you were not giving us, you were giving us a week free, and now you're giving us assignments due on Thursday.
That's because of you. That's because of you. You have a conference. You are going there. And then unitedly you have decided, let us have the exam next Thursday. Okay, unitedly you have decided. Unity is better than non-unity, right?
So that's more involved than the assignment.
Or the typing master. That is called the typing master. Nowadays, everyone may want to make money, okay? Nowadays, everyone wants to make money. You have to learn. If you, thank you asking me, you have to learn typing. Okay, you have to learn because when you enter the job, you do not know how much email, how much work you have to do. And then if your manager hire you for some reason and then ask you, and then he is super smart, and smart people always want other people to be smart. Smart in what sense? In short time, he can do lot of work. And then he give you the works, you cannot finish these things. And he said, well, I hired the employee and I have to work for him. Then why should I keep him? The next day very politely said that, well, we company has some problem, we cannot. Because he noticed you cannot perform well, he have to fire you, okay? So typing with a high speed is very essential nowadays, okay? Didn't I tell you, I came here 2006, I saw in a Ball State University computer lab, the American kids, they are typing. I just said, how did you learn these things? During that time, I also type like this way. Believe me, I'm not afraid to share my limitation, right? I said, oh, there is a game. Oh, what is that? Just 2-3 days, continuously. And if you become a master on that, you cannot believe how much time you can save. A lot of time. So check in other software. There must have something free. Okay. See you on next Thursday. If you have a question, email me. I will answer your question.
I know there's been a lot of.
I took 2 exams in one day during my PhD time. This next Thursday?
And my home is like the right thing to exam. I have it in
No, it will not. Okay, then let me see. Let me see if I can figure it out for something else.
Okay, no problem.
But you're waiting for
So if it's
Yeah. Maybe when you are fine.
I'll leave you the time, just ask you then.
Wednesday at 9.
I'm leaving here when it's.
So maybe then I can see you on Wednesday.
Okay.
Okay, you can take preparation. I will. You can email me. Okay.
Okay.
question.
Jennifer, this is